What's up, everybody? Mr. Enyard here. Welcome to Mr. Enyard's Mathematical Compositions, and today we are doing week 31, Monday. We're almost to the end of it. Let's do it. All right, everybody, week 31, Monday. We're starting with some volume. If you've been in Module 5 at all, this is basically all Module 5, and volume is length times width times height. So what we're doing is we're literally creating a layer, right, of 1 by 1 cubes, and then we're figuring out how many. So this is going to have 2 layers, right? Obviously, this millimeter goes with the 7, so unfortunately there's a very odd typo here. And then these pictures must not be to scale, because if they were to scale, this 7 over here would look the same as this 7 here. And in fact, it kind of looks like the 2. But that doesn't matter. We're given the length, the width, and the height. It has to be, height would be from the base to the top, right? The length is just left to right, and then the width is how deep it is, right? That's how I see it. It really doesn't matter since you're multiplying. It can be any order. So we're going to do, I'm going to start with 7 times 7, which is 49, and then 49 times 2, right, is going to be 98. And so I'm going to say that it is 98, and then the label for volume is going to be the units you're using to measure, in this case millimeters, but we're doing millimeters times millimeters times millimeters. That's 1, 2, 3 times, and instead of making, let's say this was 2, right, and this was 7, okay, instead of just making those squares, we're also taking it back here. Right? And theoretically, they're supposed to be 7, but I'm just going to do 2 because it kind of looks like a 2. And by doing so, we're making these cube. So if you were able to kind of visualize this, and I have a video on my Edpuzzle account and my YouTube account called Volume, and I think it's Volume and Surface Area. Good video to help you understand that we are literally making cubes right here. This is a cube, this is a cube, a cube, a cube, and each of them are 1 by 1 by 1. So now we have 1, 2, 3 dimensions that we're measuring and multiplying. Our unit is going to be the units we're using, millimeters cubed, which we can call to the 3rd power. All right, let's try number 2. So 9 times 10 times 2. Well, I'm just going to do 20 times 9, which is going to be 180. Right, so 2 times 10 is 20, and 20 times the 9, right, is 180. And then yards is our units. So we're going to write the YD, and then we're doing yards times yards times yards, 3-dimensional object, so we have to put the little cubed up there. So that is our final answer. 180 yards is the volume of our rectangular prism. So this one just wants you to be the teacher and figure out the mistake he made. If he said the interquartile range was 15, where from these numbers can you get a 15 out of? Yeah, 17 minus 2. Right? 17 minus 2. And if we did 17 minus 2, we'd get 15. And that is not the interquartile range, right? Interquartile range is the range between quartile 3 and quartile 1. Remember the last and the first quartile. So 17 minus 2 is just the range. And we're not looking for just the plain range, or the range of the data as goes from the very beginning to the very end. We're looking for what is it between the middle halves of the data. And that is the quartile 3 minus quartile 1, which would be 13 minus 8, which of course would be 5. So 5 is the true IQR, which is a big difference, right? And it's always smaller than the actual range. So here's some more unit conversion or proportion questions. You'll hear them said a few different ways. And we have milligrams and we have grams. And it tells us that there's 1,000 milligrams because millipede, milli is a prefix that means 1,000th. And then, so it takes 1,000 of these things to equal just one of these. So what's bigger, milligrams or grams? Yeah, grams are much bigger units because within this, right, this right here, that's 1 gram. It's the same as 1,000 of the milligrams. And so I'd have to cut that into 1,000 pieces, but it's the same length. You see what I'm saying? So if it takes only 1 to equal that entire thing, that is a bigger unit. So this number here is going to become a lot smaller. How much smaller? 1,000 times smaller. So we're actually going to be dividing it by 1,000. which is just taking the imaginary decimal at the end of the 4 back 3 place units, right? That's our cheat code with dividing by powers of 10. However many zeros there are is how many times you move the place value. And when you're dividing, you're moving it to the left. When you're multiplying, you're moving it to the right. So our answer is 4 and 164th, or 4.164 grams, is equal to 4,164 milligrams. Okay, so I went ahead and jumped in and did the mean because I think we're pretty good at that. So we're going to add up all of our numbers in our data, find it, make it into a lump sum, a big total, a big pile, right, which was 72. And then we're going to divide that by how many equal groups we want, which in this case is 4 because there's 4 pieces of data. And that gives us 18. But now the mean absolute deviation is the one that I know still creates some confusion. And remember, you have to make a new list. So step 1 is to make a new list of how far is each number in our data from our mean. So 13 is 5 away from 18, so I'm going to write a 5 down. 17 is only 1 away from 18, so I'm going to write a 1 down. 20 is 2 away from 18, so I'm going to write a 2 down. And 22 is 4 away. And so now I find the mean of these. I put them into a lump sum, which is going to be 12, right? You add those together, you get 12. And then you're going to divide that by how many there are, which is 4. And you get 3. So our mean absolute deviation is 3. All right, so remember to find the area of these composite figures, or sometimes it may just be one figure. You have to make a composite figure by cutting it into different pieces. But this one gave it to you. So we're going to, this centimeter obviously goes there, right? And so we're going to find the area of the rectangle, which is just going to be length times width. That's how you find area of a rectangle. So 4 times 8, right? The 4 times the 8 is going to be 32. And then to find the triangle, remember it's base times height divided by 2, or that's the same as 1/2 base times height. So what is the base of the triangle? Yeah, the base has to be the same as this over here, right? Because in rectangles, opposite sides are equal. Because these right angles, they create parallel sides on the opposite ends. And so those parallel sides that are cut by a perpendicular side are the same length. So if this is 4 centimeters, this is 4 centimeters. So our base of the triangle is 4. So we're going to do 4 times our height, which is 2. That's 8. 8 divided by 2 is 4. And now we just combine the 4 plus the 32. And we're going to get 36 centimeters. That's 6 is terrible, sorry. And that's centimeters squared because we are just finding area. And remember, area is just 2 dimensions being multiplied. So we just did length times width. Here we just did base times height. And those 2 dimensions are centimeters times centimeters in this case because we're using centimeters as our units. So it's units squared, in this case centimeters squared, as our label. And so the same thing applies to number 7. We're going to do length times width for the rectangle here, which is going to be 5 inches times 6 inches, which is going to be 30 inches squared. That little symbol there, 2 lines, is inches. You can use that. We use that a lot when we're measuring things. Anyway, so what's the base of our triangle at the bottom? Yeah, it has to be 5 because that's the opposite of the side at the top. And so 5 times 2 is 10, and 10 divided by 2 is going to be 5. So we add 30 plus 5, and we're going to get 35, and that's going to be inches squared. So that is our final area. So how do we find the area of this figure? Well, we pay attention to what it says. It is a square. And what do we know about a square? A square has 4 equal sides. So if this side is 2 1/3 centimeters, this side is 2 1/3 centimeters, and so are all the rest. And how do you find the area of a square? Well, you can do the sides squared, because you're just doing the same number twice, which is the same as length times width, or side times side, right? So 2 1/3 times 2 1/3, we're going to keep it in fractional form because thirds are irrational numbers and it just goes forever, 0.3333333. So I am, however, going to make it improper. So we're going to do 3 times 2, which is 6, plus the 1. So 2 1/3 is the same as 7 thirds. We're going to do 7 thirds times 7 thirds. And now we're just going to say we have 49, because remember you just multiply straight across, ninths. Now we're going to simplify. So how many 9s go into 49? Right, 49 divided by 9 is what this says. So 9 times 5 is 45, right? And to get to 49, that leaves us 4. So 5 and 4/9 centimeters squared would be the area of our rectangle, or square. and a square again has equal sides. But 4/9 is in simplest form because 4 and 9 cannot be divided by the same divisor to become something smaller. So finding the area of a triangle. Again, it's base times height divided by 2, right? Base times height divided by 2. You'll also see 1/2 base times height, and they'll probably be lowercase letters, but I like uppercase letters. So 8 times 4 is going to be 32, and then we're going to do 32 divided by 2, which is going to be 16, and 16 feet squared would be our final answer so that we have the correct units. Remember, units in this case are feet. That's what we used to measure. And then we're creating square units inside of that object to find area. And for our final question, we have a ratio question, right? Using ratios to find missing information. So how much would 40 gumballs cost is our question. So we got to figure out the cost of 40 from the cost of 25. So I can make a little chart or a little ratio like this. 25 gumballs, that's a G, is equal to $2.50, and that's $1. So what I want to do is I want to first get back to figure out the cost of 1. If I can figure out the cost of 1, right, a rate, we're going to use rate and ratio to help us, then I can figure out the cost of 40. Now, 5 would also work because 5 is a factor of 40, and 5 is also a factor of 25. So I'll do both. So how do we get to 5? We divide by 5, right? To make 25 a 5, you have to divide it by 5. And remember, to make equivalent ratios, we divide or multiply both sides by the same divisor or factor. So 250 divided by 5, right, is going to be 50 cents. Right, 25, imagine the decimal doesn't exist, right? 2.5 divided by 5 is just going to be, 25 divided by 5 is going to be 5, right? And then where would that decimal go? It'd move one spot to the left, so it's 50 cents. So it's 50 cents for 5. And now we could just multiply that by 8 to get to 40. But let's go ahead and take it back to 1, right? So we could have divided 25 by 10, and, I'm sorry, by 25, and we would have gotten 1, right? Or we can divide the 5 by 5, right? 25 divided by 25 gives you 1, and 5 divided by 5 gives you 1. And so 250 divided by 25, or 50 cents divided by 5, is going to give us 10 cents. So it's 10 cents a gumball, right? So if we want 40, all we have to do is multiply that by 40. So any way you choose to do this will probably still get you to the right answer. Bottom line is now we can easily get to 40, and we can take any of them. I'm going to do 5 times 8, which means I have to do 50 cents times 8, right, which is $4. So our answer is $4. And again, I have my dollars at the top of my chart, so I know what it is. And then if I did it with the 1, right, I did times 40, 10 times 40, well, 10 cents times 40 is going to be $4 as well. So these are the kinds of problems where you get to go backwards to go forward. Sorry if you hear my kids in the background. All right.